All right. Thank you very much, Samuel and David, for the introduction. Welcome to this session about smart factory. Before I introduce our speakers, I'd like to remind everyone that smart factory, industrial Internet of Things, Internet of Things in general is not new. It's been the word Internet of Things has been said the first time in 1999, last century, by Kevin Ashton. And for many years, for over 20 years now, companies like Airbus, like the US Army, like two of our companies here, like Air Liquide and Schneider, have been doing the Internet of Things, using technologies like RFID and many more. So nothing new there, but what's new? Why are we talking about the Internet of Things today? That's because three key facts, new things that happen that allow to create new business model, new products. And those three issues are, first, new connectivity. David mentioned that. I mentioned the IoT, narrowband IoT that the operators are working on, but you also have things like Sigfox, LoRaWAN. You'll have a talk by Matuma just after us. And we have also a speaker here from Ewindock, who has very interesting connectivity for indoor localization. So we'll talk about that too, first part. Second part is the availability, that's a complex word for a French person, availability of, in an economic way and in a large quantity of sensors and actuators. Sensors allow to transform a physical measure like a temperature into numerical data, and actuators do the other way. I mean, you have numerical data and you're going to act upon something. So those new technologies are available. And the third one, more important in the consumer Internet of Things, but also important for the industrial Internet of Things, are the mobile phone. We'll have mobiles in our pockets, and those mobiles are the best interface, human-machine interface you can imagine, so you can use that to talk to objects, connected objects. So with all that, plus the fact many companies now, like HomeOne, are starting to and are building services, are building all those pieces together to create services. We have a new set of new services and technology to allow the industrial Internet of Things. And that's pretty much all I wanted to say. I want to give the words now and the microphone to our four speakers. And I'll start with Laurent Julliard, who is corporate research of Schneider Electric. Schneider Electric, Jean-Paul Tricoire, who is the CEO of Schneider, mentioned in an article a few weeks ago that 45% of his business is Internet of Things. 45% already. So, Laurent, do you want to? Where's Laurent? Here. Laurent, do you want to explain what Schneider is doing with Internet of Things?
Yeah. A few words about Schneider Electric, maybe, to start with, just to set the stage. So Schneider Electric is a 27 billion euro company today, 160,000 people in 100 countries. And the best way to define Schneider Electric today is really to read our tagline that is right below our logo, which says, "Life is on." Okay, that you would translate for the French speaker in the room today, "La vie s'illumine." And this is really what Schneider Electric business is about today, is to bring energy everywhere, at any time, to every place in the world. And we do that for four markets today. We do it for buildings, such as the one we are in today. We do it for data centers, small ones, but also very big ones, like data centers for the GAFAs, I mean the big four. We do it for industries, especially for factories, and we have customers in our audience today, like Air Liquide, for instance. And finally, we do it for infrastructure, and by infrastructure, I mean cities, I mean power grid, meaning the electric grid that we use every day. So the way we bring value to our customer today, and this comes from what our CEO said yesterday in an article to a newspaper, is really by combining energy, software, and automation. And this is really how you deliver the promise of, technology, okay? Schneider Electric is a technology company. This is how we define ourselves. We spend 5% of our revenue in R&D, which is quite a large number in our sector. And what we want to make sure is that the technology we bring to our customer help you solve problems like, are you making the best possible use of your energy? Are you optimizing your production processes? Are you reducing your maintenance costs, for instance? I mean, this is the kind of questions we try to solve for our customer. And IoT and the digitization of our offer is absolutely key in solving those problems. A couple of years ago, I would say 3 years now, we defined an architecture that we call EcoStructure. So I will go into a little bit of technical terms. Basically, it's a very high-level architecture in 3 layers. At the basis of it is connected products, because if your products are not connected, you forget about all the rest, okay? So first of all, you have to have connected products, and I can give you an example later in the discussion if you want. I even brought one with me today to show you what it means. On top of that, you have another layer which we call edge control, okay? And edge control is really about controlling all those devices that you have in your premise. And your premise, again, can be a data center, can be a factory, can be a city, okay? And there is this control layer that is just next to the sensors, next to the devices that you operate. And then comes the third layer, which is about apps, about analytics, machine learning, and also about services, right? So all of our solutions today follow this 3-layer architecture. And the reason for that is because whether you talk about industries, about data centers, about cities, there has to be some level of interoperability about all the devices we sell to these various markets. Okay? So this is a very important thing for us. And we today clearly focus our actions on connected products. There is, I would say, probably not a single product that is being designed today at Schneider that goes out to the market without being connected in one way or another, right? So, and it's also true for the smallest power breaker that you see in your electric panel at home today. Those little objects that cost probably less than 15 euro have some communication capabilities today, or will have very soon some communication capabilities today. Okay, so maybe I'm going to stop here and let the others talk about their activities, and we'll come back to more explanation about connected products if you want to.
Perfect. Thank you, Laurent. We move to another great French company, not well-known, B2B company. That's Air Liquide. I mean, people know Air Liquide here, but it's a big leader everywhere in the world, in Japan and other countries. And with us, we have the CEO of Air Liquide Services, Alexis Duret, who is going to explain his involvement with his company with the Internet of Things, and especially on the manufacturing side.
Thank you, Pierre. Yes, indeed. So for those of you who are not so familiar with Air Liquide, we are a large multinational company. We are 20 billion euro revenues, and we operate in most of the countries of the world. We produce industrial gases, nitrogen, oxygen, and hydrogen mainly. And we are really into 3 kinds of business. The first business is operating plants, building and operating plants. We have over 400 plants throughout the world to separate the air that's around us and produce that gases I just mentioned. The second business is supply chain. These gases are usually produced under a liquid form, so we can distribute them either as liquid, we call it bulk, using trailers, and then delivering in tanks. Or we can use the gaseous form, and we manage over 22 million cylinders of gas around the world. So it's really a supply chain business managing assets. The third business is patient care, so that's a bit of a different business, more of a service business. We came into that business, of course, through delivering oxygen to patients, but nowadays we care for multiple forms of diseases, not always related to respiratory diseases. So as Pierre said, we are into IoT for quite some time. I will give 3 examples. We have had a SCADA system for our plants over 10 years now, relying on traditional connected networks. So you can call it IoT or you can call it traditional connected industry. We have a quite good example of connected industrial IoT by monitoring our gas tanks. So we have a commitment for our clients that they will never lack oxygen or nitrogen. So we monitor the level of these liquid tanks. And whenever they are close to a certain range, we redeliver them. And that's being done through some telemetry system that we've been operated for over the last 10 years. First on PSTN, then on GSM, 2G, SMS, now 3G, 4G. And then we are tracking these 22 million cylinders, as I mentioned, with a mix of technologies from traditional barcode to RFIDs, using PDAs and nowadays smartphones, because these assets, each of them is worth 100 euros, so it's quite a lot of money when you add it up. So you want to know where they are, and you want to invoice your clients for using them. So in some ways, IoT is not new. I think what's becoming new today is that the speed of innovation and the lowering of cost is opening up new use cases. Basically, we've did all the use cases we could do with the technology and the cost of the time. So these big bulk tanks, it was okay to monitor them through GSM, but it's too expensive to monitor a cylinder with such technology. But when it comes to low power, wide area network technologies, you can start maybe considering this. You still need to work a lot on the cost of the hardware, but at least the communication is something you can consider. There's also a lot of innovation on what you do with the data you collect. So as I said, we've been collecting production data through our SCADA systems for over 10 years, but it's only now that we are starting to roll out predictive maintenance systems. So you can call it big data, although really it's not so big as this. But the fact is there is so much innovation nowadays around these systems that it's becoming something you can't miss, and everybody is ready to jump on board. And finally, for everything that is connected, you can also have a lot of improvement in your maintenance processes. Again, multiplying the number of sensors you may have at, or the frequency at which you send data. So it's also a continuous improvement curve. It's not just a revolution and breakthrough from our perspective.
All right, thank you, Alexis. Our third speaker is from a startup, so his company is not as known as the two previous ones, but if the technology is as good as it promises, it will be well known very shortly. The name of the company is Ewindock, and it's and Eric Cariou is on my side, and the CEO of the company, and they're making indoor geolocalization system with some very nice tricks he's going to explain. Eric.
Yeah, thanks for having us on this table. My name is Eric Cariou. I'm the CEO and co-founder of a company called Ewindock. My background, I've got about 20 years of experience in the telecoms and IoT sector, serving industrial groups around the world. The reason we created Ewindock and the solution, what is the solution about, is each time over the last 10 years I've been working on industrial sites, warehouses. I ask these directors what they need to improve their management of their stocks, of their tools, and they still haven't deployed anything. And why? When you ask these guys, they tell you too costly and not efficient enough. So IoT is arriving. It's arriving through the small door because the devices are still expensive. And the solution we have provided is a way to track and locate with very simple tag, very similar to a barcode that you can stick on any product, very low cost, a few cents, on any product to be able to locate it on a continuous basis and track millions of goods simultaneously. So how we do that? We do energy harvesting using radio signals, which are going to be stored in the tag. When there is sufficient energy, the tag is going to emit a signal, and the network around will be able to locate on a continuous basis this tag and the product. So we have been selected by Airbus last year out of 150 companies from around the world. We are the only French company which has integrated the incubator in Toulouse with another company from Hong Kong, Germany, and Spain. It has been 1 year development of the solution. The production is now being launched. And we are very happy to announce that we've got 8 customers in 5 different countries in Europe, including Airbus, but also Alstom, IKEA, BMW in Germany.
Okay, so it's very impressive technology in we'll follow that. Our last speakers, last but not least, and it's not very French to keep the lady at the end, but I did that to follow a third path, is Soline Olzanski from Hub1. Hub1 is an integrator, you need a company that put all that technology together, knows the platform, knows the connectivity, knows the tool, knows the customer to build real services. And Soline and Hub1 are working with a very big object called an airport. That's what she's going to explain to us.
Thank you very much. Well, good afternoon, everybody. So I'm Soline Olzanski. I'm in charge of strategy, innovation, and development for Hub1 Group. Hub1 Group is as well a telco operator and an integrator. We provide our customers with a global end-to-end solutions that include network, hardware, sensors, for example, but also application and services. We provide our main customers, I would say, we are a 100% subsidiary of Paris Aéroport. So, our first target is transportation, air transport and transportation, retail, but also industry. We operate multi-technologies. We are telco, so we operate fixed lines, mobile, Wi-Fi. We also have RFID, and we are a leader in tracking and tracing solution in France. When I say that, I mean, where do we stand today? Where I'm here today? The point is that we've made the choice to go into the Internet of Things, and we've developed an offer that is industrial and that is commercialized today on the three main airports: Paris, Charles de Gaulle, Orly, and Le Bourget. This offer is on the table for now, and we can speak about the main use case we see for IoT. And we pursue also the research and innovation on indoor location. Well, we already have outdoor location, which is quite tricky on LoRa plus GPS, but we work also on indoor location. We are having an experiment with Carlink and RBWise on these very days. So that's where we stand. Our vision is really that we enter into a new industrial era. We have technological breakthroughs, of course. You have very huge computing power. You've got better energy storage. You've got also new protocols and new paradigm, LPWA, for example. But beyond these technologies and beyond these technology breakthroughs, you've got a business model stakes that are related mainly to the way that it will enter into a mass industry and the business model. I mean, if you manage to go to business model that are 10 or 100 times lower than what it used to be, then we will have a revolution, I would say.
Okay, thank you. When we started to prepare this session, I thought we were going to work on the dreams of what's allowed by Internet of Things, but after this morning's session, it's about trust and privacy and security. So before we move to use cases, which I've asked our speakers, can I have a word from each of you about how you handle trust and privacy in your company? I know a word is very difficult because they're all different cases, but to reassure people, I mean, those topics are handled by the companies, right? Trust, privacy, we're not in limbo here. Who wants to start?
I can do that. For us, trust and privacy is a lot about security, industrial security. Those plans I mentioned, some of them are quite critical for the countries we are operating in. And until now, they were connected because we collected production data, but it was just for read-only, right? So we were collecting data and using that to monitor our operations. Now we are changing. We have a big program to operate all of our plants, for example, out of France in one city, in Lyon, which means that we are going to send orders to the plants remotely. So it's becoming now critical to make sure we are absolutely 100% sure that the way the network, the plants are connected, and every connected device and every piece of the infrastructure that is used in this process is absolutely secure. And until we've got this certainty, we won't go into production. So to make it very concrete, we are making tests, we are making intrusion tests, we are hiring hackers to do that, because we want to be sure that we won't suffer those pains.
And if I remember correctly, you mentioned during the call that you were under attacks. You already measured attacks on your site already.
Absolutely. There were some local attacks on some of our plants, not very brutal, not too dangerous, using security flows because you've got some people taking bad local initiatives. But it was still isolated plants, so the damage is relatively minor. And they couldn't really access to the control system of the plant itself. So it was more into the corporate network around it. But now the stakes are changing really with IoT.
So security is real, but the companies are taking care of it. Yes, Laurent, you wanted to take the mic?
Well, my answer is almost along the same lines because, first of all, we are lucky enough at Schneider that we don't manipulate any data related to individuals, right? So this is a big plus because it means that most of the information that we carry over our connections are related to processes, are related sometimes to people, but it's always about a number of people, or like in a building, for instance, how many people in a room or how many people in a hall, in a hallway, etc. There is no individual information. So this is one. The second thing is, nevertheless, we pay a lot of attention to the security of our information, exactly like what you said. And when I talked about this 3-layer architecture earlier, I didn't have time to tell you that there are a couple of things that cut across those 3 layers, and one of them is cybersecurity, okay? So we make sure that from connected products, from individual sensors, up to our data lake, where we store all the data coming from our customers, all data is encrypted and safe, okay? And we do have as well people like doing what we call penetration testing. I mean, testing our products all day long, making sure that no one can penetrate them and use them for purposes that were not intended in the first place.
Anyone want to add something to it? No obligation, yes?
Yeah. Well, if we look at our solution, the tags do not contain any memory. There is a unique identifier written on the hardware. So there is no way to address, to hack any of the tags we are deploying on the products. Now, one of the weak point potentially of any solution is when you store the data. We've got 2 options there. We have a standalone server that some customers, especially in the defense industry, for example, don't want to have any data coming out. So all the processing is done in-house, and there is no connection with the outside world. And there is a cloud-based solution, which is always slightly less secure, even though it's encrypted. But that's the way we address security. So there is no way the tag can be hacked or read from outside.
For us, well, I can say that well, we are secured by design. I mean, with well, the design of our solution. Well, we encrypt, of course. We use encryption in the network. We have passwords. We have developed ourselves our software application, and we collect and store our information in our own data centers. So for this part, I think we can have trust, and our customers and partners can trust our solution. Something which is for us much more tricky would be whose information is this? I mean, we gather information from several types of actors. In an airport, you've got the airport, but you've got also many other actors. If you take the example, for example, of a luggage container. If you take a luggage container, whose information is this? Is it the airport? Is it the security? Is it the leaser of the container? Or is it the user who's you know, an assistance company or any other company? And there's still, we are less on the privacy part because we are professionals, but the question still of the data lake and who is using what, without selling it, but still who is using what type of data is still really important for us today.
Okay, good. So now we've seen the privacy by design and security by design. Let's see the dream by design. What kind of a use case, what kind of exciting products you've all been working on that could show example to the audience here? Products that, I know some of you can't talk about some products that are coming, and I remember some I'd like to talk about, but I won't. But you all have been working on real products. What kind of use case, what kind of cost reduction, what kind of new return investments you can describe to the audience? Any of you? And no answer would be a bad answer.
So I think Air Liquide's motto is creative oxygen, so let's dream. No, I think we haven't talked a lot about the connected health so far, but that's something that everyone's dreaming about. I think it was mentioned during Verizon's presentation. I mean, everyone's seeing that patients monitoring at home is going to go through technology. But this has been a thinking that has been going on for the last, 10 years maybe? And today still very little is happening. So for me, the dream is the breakthrough on the patient monitoring solution. From a technological point of view, there's been tests, demos and everything, but the reality is that the business case still doesn't fly. So for me, the dream is really about lowering costs. It's really my main dream at the moment.
Yes. Anyone for interesting use case to share?
Well,
go ahead, Laurent.
Being at the head of research at Schneider Electric, I brought a couple of things with me. We are talking about things, so I want to show you a few things that came out of our research lab. And actually, this one that you see here, so it might be difficult from the far end of the room to see it because it's so small. This is a sensor that will be on the market within a few weeks from now. And you remember the previous speaker talking about if it's not autonomous, it's not IoT. I would go even one step further. If you cannot forget about it, it's not IoT, right? So all the objects you're using to deploy an IoT type of application, you should be able, all these objects, you should be able to forget about it, meaning you fire them up and then you forget them. And so this is exactly the goal we're pursuing with those smart sensors. So this one here that you see here is actually going to be used in one of those concrete shelter that you probably see in your area where you live, where we deliver medium voltage electricity, like 20 kilovolts. That will then feed your area, hundreds of houses, and you have 50,000 of them throughout France. And of course, for safety reasons, you can imagine that nobody enters this type of shelter because it's so dangerous. The tricky thing is that the inside of the shelter is so harsh in terms of temperature, in terms of electromagnetic environment, that until very recently, it was absolutely impossible to have sensors in those shelters. And by temperature, I mean it can go up to 100 degrees, for instance, in summer, in certain places in the shelter, and the electromagnetic environment is really very violent. So thanks to the, what microelectronics is capable of doing today, this sensor that you see here, we will be able to stick it on the electric cable, no battery. The power is coming from the electromagnetic field that is so intense in the shelter, okay, no battery at all. And this sensor will send two information once a minute, temperature and intensity of the current. All this will be transmitted through Zigbee, although the electromagnetic environment is so harsh. I mean, we can transfer the information. And literally, those little things will be in the shelter for as long as the shelter will live. Okay? And nobody will enter this shelter to change the battery or repair the sensor. Okay? So this is very important that for IoT to deliver its promise is to have objects that are really smart and really tough, at least in the industrial world. I don't know about, probably in the consumer electronics, the story is different. But in industry, clearly, it has to be that way. Another innovation, if I have time.
Sure.
Okay. Another innovation, so this one is for real, right? It's on the market in a couple of days. The other one is a little bit more longer term. In our research labs today, we're working on something that we call virtual sensors. And as the name says it's not a physical sensor. It's a sensor that does not exist. So what is it all about? The idea is that in all the things you can measure today, there are probably things that you can infer from what you measure that is not obvious in the first place. And you were mentioning the milk industry in your introduction. And this is something we have done for a big customer in the milk industry. They were having problems with one of their processes, transformation processes. And they were, in the process of transforming the milk, at some point they were having very strange behavior which forced them basically to throw out the whole batch of milk that were being processed because it went south, by the way. They didn't understand what was happening, but something went wrong. And it was obvious that they did not have the sensors to measure that, because otherwise they would have solved the problem in the first place, right? So what we offered them was to say, well, give us all the data you have about anything in your area, in this particular area of the process, but what I mean anything is anything, okay? So it was the temperature of the building, it was about, I don't know, the people entering the parking area, I mean, everything, okay? And basically you throw all this data to, it's not really a machine learning algorithm, it's another kind of algorithm, saying, is there a way by which we can correlate the problems that you are seeing on your production line with any of the things you are measuring, or a combination of what you are measuring, okay? And it turned out that in the process of doing so, and you won't believe it, it's absolutely incredible, we managed to correlate the problems they were having with the number of times somebody was pushing on a push button elsewhere in the building. And this push button turned out to open the door of the room where the process was happening. And of course, I mean, it was indirectly measuring the number of times people were going through the room while the process was running. And the conclusion they came to, and they knew that beforehand, they knew that the process was very sensitive to humidity. But they didn't think about it because to them the humidity level was stable and there was nothing wrong about that. But it turned out that the number of people entering, getting in and out of the room were enough to change the level of humidity in the room and ruin the process and the batch. Okay, and so this is what I call virtual sensor, and this is a very promising technology actually.
Excellent. What? Yes.
Yeah, just maybe one use case. We work with a number of manufacturers and equipment integrators, and one of them has got about 40,000 tools. Each of these tools costs about 30,000 euros, and every year on the manufacturing sites, they've got about 80, 90 manufacturing sites worldwide, they waste tens of millions just in replacing these tools on a yearly basis because they lose them. Not only they lose them, but they also have to recalibrate them. So to recalibrate them on a regular basis, the way it works today is the head of the manufacturing site has got a list on the Monday morning of all the 120 tools they need to recalibrate that week, and they spend almost a week, one person, just finding all the tools around the manufacturing site. A manufacturing site is not just your garage. A tool in your garage, 2 minutes, you have found it. A manufacturing site often is 200 meters by 300 meters. It's kilometers of walking every day if you want to find things around. So that's one simple example of how you can track and locate. So today with this solution, this is the kind of tag you can stick, which is moving into production today, stick on any of your product. You can find and locate all your 120 tools, have an optimized route to pick them up, to do the picking around the factory, to get them in less than an hour. So that's one of the examples, more focused on tools. With this data, you can also look at how these tools are used. A lot of the recalibration happens linked to the date it has been in the manufacturing site, but sometimes some of these tools are not even used because they are lost in one of the cupboards somewhere in the site. So basically there is a lot of over-calibration. Some of the tools don't need to be calibrated because they haven't hardly been used. The productivity of the technicians is reduced because of the time they waste finding the right tools. They tend to overstock the tools because they need to have them. They cannot stop the production. So it's a lot of induced costs which are not actually directly linked to the tools themselves, but for the impact on production. And when you have a linear production, when you have a car, when you have a plane stopped in the production, it's an absolute nightmare. The consequences can be huge in terms of cash flow because you cannot cash in the money if you don't deliver your product. So that's one of the examples. Another example is more about managing warehouses and stocks. If you look at the airline industry, If you have got what we call an aircraft on ground, which is, for example, an EasyJet plane having a technical fault on an airport in Tallinn, the cost for the airline is about 500,000 euros per day, wasted waiting for parts to be supplied and delivered on the spot of the where the plane is. So what they do is they call companies which need to be able to answer within a few minutes whether they have the spare parts and how far and how fast they can deliver it on the spot under the plane. And today, in fact, a third of their business is lost because they have ideas about the fact that they have the product in the warehouse somewhere, but they cannot actually answer within the 2 or 3 minutes which is required by the airline. So the airline goes from one to the other supplier and they move on, and a lot of the business is lost that way. So the efficiency in managing warehouses today, and we see even some of the best logistic companies in the world, there is a lot of room to improve, and in terms of productivity, in terms of lost business, and yeah.
Excellent, real cases. Yes, go ahead. Go ahead.
Maybe we can share well, the use case we see in the airport and in the industry. I would see 4 main fields of use case. The first one would be the following: the monitoring and the supervision of the buildings. Wherever it is an airport, here, this building or any other, you need to know what is the temperature, if your doors are closed or open, and all this stuff that makes your life simple and better performance anyway. First point, building. Second point is the following of the assets in these buildings or outside the buildings. People usually lose assets, and believe me or not, that's really an issue today. To find the right thing at the right place. Third one would be to follow the operations. And in your very specific operations, some industrials need to follow the very specific milestones of a maintenance process, for example. And we couple several technologies in order to offer them a solution for that. And I would say that the last need we see is SLAs. I mean, people need to provide their customers with proof that the work is done. And they need to prove that the temperature is a good one in the truck when transporting your food. They need to prove that the humidity is okay in the cigar cellar. They need to prove that the lady came and cleaned up the zone. And all these SLAs are really also a very huge field for use cases.
Excellent. You all been working on Internet of Things projects, business one. You have, because we're running out of time, a piece of advice for any companies in the room that would like to start. What things that are not thought to start with, that you're discovering after a project? How people should handle the start of a new project in Internet of Things? And I'm asking the question because one of the person here in the room, don't want to say the name, but said that they had some projects that were not as good, they were too early, and they had to stop them. So I'd like you to share your experience about successful, not as successful, so people in the audience, when they start, they think, hey, I have to think about the human part, I have to think about maintenance part, I have to think about any insight you want to share with how you handle a project, Internet of Things specific project.
I know the advice I would give. I know that IoT and all the technologies that relate to IoT are all very often seen as being disruptive, and you may have the feeling that it really needs some adaptation and trainings and etc. to get up to speed with it. But my advice is, especially in factories, even in factories that are maybe 10 years old or 15 years old, it's a good starting point to do digitization and IoT. At Schneider Electric, this is what we call secondary sensing. Secondary sensing is really about bringing sensors in your installation without disrupting your installation at all. Okay, like it's sensors that you stick to places here and there. You don't have to wire anything. You transmit the information wireless. You collect it wireless. You analyze it remotely, and it brings a new dimension to your industrial process, actually. And this is something you can do quite easily, okay? We do provide solution for that, and this is a very smooth way of entering the IoT world.
Okay. Anyone else?
Yeah, maybe one advice, I don't know, because I'm not entitled to give advice to anybody. We are still a young company. But one thing which is sure is everybody talks about Industry 4.0 and digitalization. One of the key enabling thing is cost. It reminds me, a few years ago when I was in London, there was Stelios presenting EasyJet business. And when he presented his business, other executives were asking him, well, listen, I mean, you've got 30 airline companies in Europe. How are you going to make money out of that? And the thing is simple, was simple for him. It was like Paris-London flight was 600 euros at the time. And he was saying, we are bringing a flight between Paris and London for 50 euros. And the addressable market is very different. So the point I want to make is this is a game changer. As soon as you start digitalizing your supply chain, and not 1% of your stock, of your tools, because that's not going to change anything in your business, but if you start tagging hundreds of millions of products, that's going to impact massively your business. So the two advice are get on board the end users on the floor in the factories and the CEOs, because it's such a change in your business. You need to get the full support from the direction of the company.
Excellent.
Well, I would say that anyway, IoT will follow the usual best practice of IT. I would say open standards, evolutivity, scalability, etc. Scalability, etc. But the main question you've got to ask before entering this kind of project is, what are your main objectives? I mean, what is the use case you want to follow? What about your existing SCADA or any existing industrial park? And what will be your data lake today and tomorrow? And that's what we'll ask.
Okay. Is Samuel here? How much do we have? How much time do we have? And can we ask questions from the audience?
Yeah, maybe we can have one last question.
From the audience?
Yeah.
Any questions from the audience then?
If we are quite late, but we can grab a question from the audience, if you have one. Otherwise, we can go.
There is one. Yeah.
Okay, there is one, which is the next speaker.
Thank you. Just a question regarding the technology the stickers were using in terms of network, because it sounds very promising, but I was just wondering which network it connects to.
It doesn't connect to any network. The tag itself harvests energy, sends a signal being detected by beacons around the building. The distance between the beacons is between 30 and 50 meters. And then it's brought back to the server. We are totally agnostic. We've got several types of ports on the beacons. We can have Wi-Fi, LoRa, but LoRa has got limitations on the volume of data you can transmit. So if you are managing hundreds of tags, it's fine. If you're looking at thousands of tags in a zone, you will be limited. But then you've got Ethernet cable and so on. So, and then from the outside point of view, it's all IP. So as soon as you're on server, it can go on the cloud. Any technology you can do. There is no specific technology there. A pleasure.
If I may add something, I think you touched to a very important point. Like we have a bunch of communication protocols today, a myriad of them, I would say. And it might seem complex, but each of them has certain very interesting properties that you can use depending on the context where your sensors is being used. Like these ones, for instance, you can easily use Zigbee and LoRa, the long-range radio protocol, that are extremely resistant to noise and stuff like that. I mean, environments that are really difficult. So that was just to add on to, that's the reason why you have so many protocols today, okay, basically.
Yeah, sorry, just to complete the answer, because maybe I misunderstood part of your question. The communication channel between the tag and the beacon, if that's your question, is a protocol that we have developed. In fact, we have asked a number of our clients who have tested a lot of technologies. The problem in industrial sites is you have got a lot of metal. And metal and radio signals don't work very well together. It's like water and fire. So we have developed a very extremely robust technology, which means that you can use in warehouses where you have got a lot of metal shelves, industrial sites where you've got a lot of metallic tools, and that's something we have patented, and we are starting to license to third-party industrial players who want to develop solutions using Ewindock inside.
All right. Should we conclude with that, Samuel?
Yeah. Thank you very much.
Okay. Well, thank you very much to Laurent, to Celine, to Eric, to Alexis. And those are real case, real Internet of Things projects, and I'm sure we can talk to them afterwards. Thank you very much.
Thank you.